So we're on to question 9. Again, it's 50 marks, and my email there is on the screen if you have any questions or comments about the marking scheme. So this is a water question with some pH calculations. So in the treatment of water for drinking, what substance is added, firstly to promote the settling of suspended solids, secondly to prevent waterborne diseases, thirdly to raise the pH, fourthly to protect against tooth decay, and what term is used for the process involved in part 1. So to promote the settling of suspended solids, you have any one of those options there: aluminium sulfate, aluminium chloride, alum, iron sulfate, iron chloride, iron polyelectrolytes, or lime. So any one of those for 3 marks. To prevent waterborne diseases, we have chlorine or Cl2, hypochlorite or ClO minus, ozone or O3. Part 3, to raise the pH, we can use lime, or just use the chemical name and formula for it, calcium hydroxide or CaOH2, sodium hydroxide or else caustic soda or NaOH, sodium carbonate, Na2CO3, or soda ash. To protect against tooth decay, we can use fluoride, F-, hexafluorosilicylic acid, fluorosilicate. And then the process in part 1 is called flocculation. Is the drinking water obtained as a result of the above treatment totally pure? Give a reason for your answer. No, it's not, because it contains the chemicals that have been added as part of the treatment, and it also could contain other dissolved gases or ions, so it's not pure. And we have 2 definitions here. So pH is minus log to the base 10 of the concentration of H+, or you could say minus log to the base 10 of the concentration of the H3O plus ions, or you could just write it out, negative log to the base 10 of hydrogen or hydronium ion concentration in moles per liter. And then Kw is equal to the concentration of H+ by the concentration of OH-, or again, you can change H+ to H3O+, or you can write it out there as you see, product of molar concentration of hydrogen or hydronium ions, or you give the formula and hydroxide or hydroxyl or OH minus in water. Okay, so that's 3 minus. That should be OH minus, not OH plus. Okay. If the value of Ka for methanoic acid is 1.9 by 10 to the minus 4, what is the concentration of a methanoic acid if the pH is 2.36? So pH is 2.36, and you need to be able to convert pH into H plus ion concentration. So H plus ion concentration is 10 to the power of minus the pH, and our pH in this case is 2.36. So that turns out to be 4.365 by 10 to the minus 3, or 0.004365, and 3 marks for getting that far. We then use our formula where the H plus concentration is equal to the square root of the Ka by Ma. Ma being the molarity of the acid. Okay, so we've worked out H plus, we're given Ka in the question, throw them in there, you square both sides, you get 1.905 by 10 to the minus 5 on the left hand side, divide across by 1.9 by 10 to the minus 4, and we get our molarity as 0.1, and moles per liter, 3 marks for that, units not necessary. Part 4, the pH of an aqueous solution at 25 degrees Celsius is 12. What is the concentration of hydroxide ions in the solution? So we're told that we know that Kw is, as we've shown in our definition earlier, is equal to the concentration of H plus by the concentration of OH minus, and that's equal to 1 by 10 to the minus 14. pH is equal to 12. So again, we get our H plus concentration from the pH, so it's 10 to the minus 12, or you can write that as 1 by 10 to the minus 12. If you had 10 to the minus 12 here, you get the 3 marks, no problem. Okay, so we're told in the question that H plus by OH minus 25 degrees Celsius is 1 by 10 to the minus 14. So we sub in for H plus from what we just calculated, 1 by 10 to the minus 12, or 10 to the minus 12. And from that we get our OH minus ion concentration, which is 0.01. So 3 marks for that. Now, on to part 3, and I know there was an issue here with the marking scheme and matching up to the question. So this is the question that was in your paper, and this is the corrected marking scheme. I corrected I've changed the paper, but unfortunately it wasn't changed in the editing, and so the marking scheme didn't match up. But on the next slide, I'm going to give you what should have been the question matching up to the marking scheme you have in your paper. But obviously this slide I'm going through now, you would use that for marking your own paper. Okay, So a lab technician collected a sample of pure water for analysis. He measured the temperature and found it to be 50 degrees Celsius. He found online that at 50 degrees Celsius, Kw is equal to 5.52 by 10 to the minus 14. From this value of Kw, he's able to calculate the pH of the water sample and treated the water with a chemical based on the calculated pH. What was the pH value he calculated? What chemical might he have used to treat the water? And was he correct to add this chemical to the water? So we know Kw is equal to 5.52 by 10 to the minus 14. Okay, we're told it's pure water. Okay, so here we have H plus by OH minus is equal to 5.52 by 10 to the minus 14. But because it's pure water, the H plus concentration is equal to the OH minus concentration. So we can, instead of OH minus here, we'll put in a H plus to get H plus squared. And we get the square root of both sides. We get 2.35 by 10 to the minus 7. So if we're getting that far, you get 2 marks. Then you get the pH by getting minus log to the base 10 of the H plus concentration. And we get 6.63 is our pH of the water. So 3 marks there. What chemical might he have used? Well, it looks like it's a little bit acidic. So in order to raise the pH, he would have used lime or sodium hydroxide or sodium carbonate. And was he correct? No, he wasn't, because the water is not acidic. The reason it has a pH of 6.63 is because Kw is temperature dependent, and it is pure water, so it's neutral. But you get the 3 marks there, just for saying no, and Kw is temperature dependent. Okay, so just for saying no, he was wrong to correct to add it, and the fact that because Kw is temperature dependent. Okay, so on the next slide now. So that's the marking scheme for the paper you have. This is the solution that is in the marking scheme that you were emailed, and that's the question that should have been asked. Okay, and all that changed was at 10 degrees. Okay, Kw is 2.9 by 10 to the minus 15. So you have the exact same way of working it out. It's pure water. Here you replace the OH with the H plus, you get H plus squared. So you get the square root of both sides, you get 5.39, and in this case, you get a pH of 7.27. So it looks like it's basic, but it's not. But what the lab technician might have been tempted to add was some carbon dioxide or sulfuric acid to lower the pH. But again, the same reason. So this solution is in your marking schemes. This should have been the question. It wasn't. So the previous slide is the marking scheme you will go by. But I just wanted to show you this from just to as a teaching tool, really, just to see where what the question and answer should have been. That's fine. So that's question 9 for you. Apologies for the mix up with the question there, but hopefully this clears it all up for you. Okay.